This is Lesson 32, Session 3, Develop, representing relationships between quantities. Mel has $10. He sells apples for $5 a bag. How much money does Mel have if he sells each number of bags? So if he has if he sells one bag, then he makes $5 off of that, and he already has $10 to start. So if he sells one bag, then he has $15. If he sells two bags, 2 times 5 is 10, plus the $10 he already has is $20. If he sells 3 bags, 3 times 5 is 15, plus the 10 that he already has, that would be $25. And if he sells 4 bags, 4 times 5 is 20, plus the 10 he already has, Mel would have $30. All right, try it on page 669 of your workbook. Jenny has saved $20 in a bank. She earns $10 an hour washing cars and saves all her money. Graph points in the coordinate plane to show the relationship between the number of hours Jenny works and the total amount of money she has saved. Include the following in your graph. Titles for the x and y axes to show which quantity each axis represents, and points for 0, 1, 2, 3, 4, and 5 hours of work. Okay, pause the video and try it out yourself and then press play. So we're going to put hours worked along the bottom here. And then over here, we're going to put total saved. All right, and then we're graphing the points 0, 1, 2, 3, 4, and 5. So each hour that she works, she earns $10. So she already has 20 right here. So if she works 1 hour, she earns $10. And I guess we need 0 too, so she already has $20. So she works 0 hours, she has her $20 in the bank already. So here's 0 hours, and then 1 hour, she gets $10. Another hour, she gets $10 more. And then for 3 hours, she gets $10 more. And 4 hours, she gets $10 more. And 5 hours, she gets $10 more. So we can see the pattern there. Model it. You can use a table to model the relationship between the quantities. The table shows the number of hours Jenny worked and a total amount of money she has saved. So for 0 hours, she has 20, and then we go up by 10 each time. Each time she works another hour. Picture it. You can graph points in the coordinate plane to model the relationship. Use the data in the table to form ordered pairs to graph. The coordinate plane at the right shows points plotted for the first 2 columns of the table. The ordered pair 1, 30 is the ordered pair that represents the total amount of money, $30, that Jenny will have after working 1 hour. Connect it. We are at the top of page 671 of your workbook. Look at the coordinate plane and picture it. What does the x-axis represent? The x-axis represents the number of hours Jenny works. What does the y-axis represent? The y-axis represents the total amount of money Jenny has saved. Number 2. Complete these ordered pairs x, y, where x is the number of hours Jenny works and y is the total amount of money Jenny will have saved. So she already has $20 in the bank. So for 0 hours, she'll have $20. For 1 hour, 30. After 2 hours, she'll have 40. 3 hours, she'll have 50. After 4 hours, she has 60. And after 5 hours, she has 70. So here's our ordered pairs. Plot the missing ordered pairs in the coordinate plane and picture it. I'll let you go back and do that, and then press play again to continue on to number 3. How much money will Jenny have saved if she works for 5 hours? Jenny will have saved $70. Which point on the graph shows this? The ordered pair for that point is 5, 70. Number 4, how many hours does Jenny need to work to save $40? She needs to work for 2 hours. Which point on the graph shows this? The ordered pair for that point is 2, 40. Number 5, how can you use the coordinate plane to represent relationships between two real-world quantities? So an example of an answer here is you might make a table showing pairs of values for two quantities to keep them organized and organize the information to form ordered pairs to graph. Number 6, reflect. Look back at the strategies. Which models or strategies do you like best for graphing points to show relationships between quantities in the coordinate plane? And explain. Number 7. Ferran works in an ice cream store. He uses 2 scoops of ice cream for each ice cream cone he sells. Make a table of values and then graph the points on the coordinate plane to show the relationship between the number of ice cream cones Ferran sells and the number of scoops of ice cream he uses. Include the following in both the table and the graph. Titles to show which quantity is represented by X and Y values, and data for 0, 1, 2, 3, and 4 ice cream cones. So we're going to fill in, I'm going to do the number of ice cream cones first, and we need 0, 1, 2, 3, and 4 ice cream cones. So the next one, this value right here, would be the number of scoops. So number of scoops would be our Y value. And our problem here says that he uses 2 scoops of ice cream for each ice cream cone he sells. So we have our value of the number of ice cream cones, and we can multiply that by 2 to find the number of scoops of ice cream he uses. So if he has 0 ice cream cones, then there would be 0 scoops. For 1 ice cream cone, each ice cream cone is 2 scoops, so 1 times 2 is 2. For 2 ice cream cones, 2 times 2 is 4. 3 times 2 is 6. And 4 times 2 is 8. So the first one is 0, 0, which would be right here at the origin. That's no ice cream cones and no scoops. The next one, we have 1, 2, so we go over 1, up 2. I guess we should say that this is the number of cones, and here we have the number of scoops. Okay, so we did 1, 2, now we have 2, 4, so that's over 2, up 4, and we should start seeing a pattern on our graph here as well. 3, 6 is over 3 up 6. And then 4, 8 is over 4 up 8. Number 8. Use the table and graph in problem 7. Where would you put a point on the graph to show how many scoops of ice cream would be used for 5 cones? Explain your answer. So I'm going to fill in real quick what we had on this graph on the previous slide. So the problem is asking how many scoops of ice cream would be used for 5 cones. So we can add a number 5 to the end here. And we know that there's 2 scoops of ice cream for each cone. So we can take 5 times 2 and continue our pattern there to get 10. And so if we put that on our graph, it would be over 5 and up 10. So we can see that pattern continuing. What does the point 2, 4 represent in the graph above? Does it represent 2 scoops of ice cream are used for 4 ice cream cones? 6 scoops of ice cream are used in all. 2 ice cream cones use 4 scoops of ice cream, or 8 scoops of ice cream are used in all. So the first number, we can see the X represents the number of ice cream cones, and the Y represents the number of scoops. So if we have 2, that's the number of cones. I'll put C there so I can remember. And 4 represents the number of scoops. I'll just call that S for scoops. So that's 2 cones using 4 scoops. So let's see which one maps that, or matches that. 2 scoops of ice cream for 4 ice cream cones. So here we have 2 cones and 4 scoops. So not that one. 6 scoops of ice cream. Nope, here we have 4 scoops of ice cream, so not that one. 2 ice cream cones use 4 scoops. So 2 cones, 4 scoops. That one's a possibility. Let's check the last one just to be sure. 8 scoops of ice cream are used in all. Nope, because it says 4 scoops. So not that. The answer there is C. 2 ice cream cones use 4 scoops of ice cream. Your assignment for session 3 is pages 673 and 674 in your workbook.